9.6 equation of lines and planes. First of all, let's do a 2x2 vector of 4 and 3. So if I graph that, and you graph it too, the initial point is going to be 0, 0, 0, or 0, 0. So that's our initial point. So 1, 2, 3, 4, 1, 2, 3. So everybody draw that vector. Okay. All right. Good? Everybody thinks this is easy now, right? This part's easy. Right? I'm serious, when we're done, I hope you think it's still easy. All right, so what happens when I say 2 times that vector? What does that mean?
Stretches.
To what? That's correct.
8 and 9, 6. Wow.
A6. 5, 6, 7, 8, 4, 5, 6. Okay? So basically it just gets bigger, right?
Yeah.
Well, what happens if I say, I'll write it over here, -3 times that vector? What happens?
It goes that way.
The other direction, what do you get?
-12, -9.
12 minutes. 1, 2, 3, 4, 5, 6, 7, 8. So it goes this direction. Straight line, right?
Oh, right, never mind.
Yeah.
Straight line. Excellent. Well, can't we come up with some way of saying this without giving every possible scalar? Remember, these are scalars, what we're multiplying by. Should be a way to do this. So look, instead of just using every possible number, we're talking about real numbers, let's just say t is going to be that number. We'll let t be the variable that covers all the numbers that we could choose. Okay? So, what would the new vector be? 4t and 3t. Starting from the initial point 0, 0, right? Now, if we start from someplace else, that'd be a little bit different. So starting from 0, 0, 4t, 3t would cover all of these vectors, wouldn't it? So for all the values of t's that I can come up with. Excellent. So this is our x position, that's our y position. So x is going to be equal to the 4t, and the y position is going to be equal to the 3t. Would you agree? Alright. These two things are called your parametric equations. That's what this lesson's about, parametric equations. And you just figured out how to come up with it. The issue is, you got to know your initial point. So here is what they show in the book. So R is our vector that we came up with, that had all the information with the t and all these other scalars that we use. That's R. And what you do is you take R sub 0, which is your initial point, y sub 0, x sub 0, y sub 0, and we're going to go back to 3 dimensions here, z sub 0. So that's a coordinate, that's your initial point. That's what R sub 0 is. And you're going to add t times your vector. And we'll just say the vectors A, B, and C. So what we come up with is the x position of our vector that we came up with is the initial point plus the vector position times t. That's what you said here, right? The initial point 0 plus 4t. That was this one. What is the y position going to be in your vector? Y sub 0 plus bt. And what's z going to be, Kyle?
Z0 plus CT.
Yeah. So, in your, or on your reference sheet, I would write this. Parametric equations. So that you can remember how to come up with it. if you look at this in your book, that doesn't really tell you anything unless you remember what r sub 0 is and what t times b is. But this is how you actually figure it out. This being your vector and that being your initial point. And this goes for any initial point. So we're going to do, half of your assignment is this right here. Okay? So we're going to do a couple examples to get started. So this, let's start with number 4. Alright, so your initial point P is 0, negative 5, 3. And your vector is 2, 0, negative 4. So I'll do this one with you, even though I think you can do it. I want the parametric equations that have this initial point and that vector. So x, the first part of my parametric equation, I'm going to do x, y, and z. What do you think x is going to start with? 0. So all of these go right here. This is the first part, right? X sub 0, y sub 0, z sub 0. It's your coordinate, your initial point that you're starting with on all of them. Who's with me so far? Okay, now, what was next? Plus, what's A, B, and C here? Your vector. So we have 2, 0, and negative 4. And this is all times what? T. Alright, now let's just clean it up here. X equals 2t, y equals negative 5, and z equals 3 minus 4t. Everybody take a look at that, make sure they understand it. So that's getting your parametric equations. What is that? What is it that we're finding? We're finding equations that cover all possible vectors starting at this point and having the same direction as this vector. That's what you just figured out.
Is that finished?
Huh?
Is that finished?
Yeah, these are your parametric equations. This is the answer right here. Got it? Alright, now you do this one on your own. Do number 8. I'm going to change it just a little, but don't freak out because I think you got this. Your initial point is 1, 1, 1. I'm trying to make it really difficult. Your vector is I minus j plus k. Give me your parametric equations. Looking decent. You can erase all that. Actually, leave this here. You can erase that.